Yeah, so as I explained already, I'm going to talk about the work we did in collaboration with the museum. So we created and deployed an exhibit inside the museum. And today I'm going to talk to you about the design process and the design rationale we used as scope of this work. So the work was done in collaboration with the museum. And so as the author team, it's together with my colleague, which is called Christian Moll, and João Martins from the museum. Yeah, so first a little bit about the context. So the Tudor Museum, it's a very small museum which is located in Rospor, which is a small village, let's say, in the border to Germany, in Luxembourg. And well, here you see an image of the museum. So it's the original house of Henri Tudor. And the idea is inside the museum to show a little bit about the life of Henri Tudor. So Henri Tudor is an inventor. To show about his life, to explain how he lived and what led to the invention of the battery at that time. It's 300 square meters. And it started off with more traditional exhibits like old batteries and old battery plates and so on, but then moved progressively more to more interactive exhibits. So you see a few pictures there. In the middle, the picture shows that one idea also in the museum is to recreate a little bit the atmosphere of that time. So to have, I don't know, when you enter the first room, it's very dark so that the visitors, the experience how it felt at that time when you didn't have electricity and when you had to work with oil lamps and candles. And here on the right you see one of the rooms which is more an experiment room where the school classes can come and they can do different types of experiments with electricity to understand the science behind electricity. So since it's not that central in Luxembourg City, the number of visitors are also not that high as compared to maybe, I don't know, Boston Science Museum or something. So they had like 700 visitors per year, for instance, and like 120 guided visits. So it's not necessarily that every day there is one visitor also, just to give you a little bit the context. Yeah, now about Henri Tudor. So he's a Luxembourgish inventor, and what he did not invent the battery itself, but he made the battery ready to use. So before there were already people who managed to show that they could have a capacity on the battery, but their processes, either the problem was that the capacity was very low, or they took like a year to be ready to use, so it took a year of forming the battery until it was ready to use, or they broke like after 2 weeks when they were ready to use. So Henri Tudor, he proposed a design of the plates, what you see there. So he created some groove inside the plates, and this then allowed to increase the surface of the plates, and with this, so the capacity could increase. And the second thing he did is that to reduce the forming time, actually, well, when forming the battery, you have to thicken the layers on the plates. But this took up to a year. So one inventor proposed already to put some kind of paste like lead oxide directly from the beginning. And this reduced incredibly the time, like it was only more 4 weeks. But then this fell off. So what he proposed was to form a little bit at the beginning and then put this additional paste onto it. So it was like a new process. And with this process, then the battery lasts like 20 years or something. Yeah, so this was a core idea. Like, I mean, the museum is about Henri Tudor, so we have to explain the visitors this idea, although it's a bit complex. And previously, this was done in this exhibit. So, yeah, basic concept is that you contrast the invention of Henri Tudor with previous inventors, and then you see with some graphs how the capacity is increasing and how it is decreasing again because it's breaking. And you have a series of drawers and you can take them out and you see how the plates would look like. So is it the layers of increase already, thicken or not, and did they break or not. So when you wanted to look at it, you first have to read very carefully what's happening, and then if you open the drawers, you have to look from the side, and well, usually you open 1 or 2 drawers, and then, okay, I basically got it, and then visitors, they moved on. So it was not really engaging. It was a bit difficult also to understand because you could not compare 2 different drawers. So the museum manager, he was really not happy with it, and, well, he called it the monster. And then came up this idea of making this more interactive, more engaging, and more comprehensible. So we talked and we came up with this idea of the project. And yeah, we set up a series of goals. So we want to support a learning by doing approach. It should allow the visitor to experience the atmosphere of and tools of the time of Tudor. It should be easy to use and to apprehend. The exhibit should be engaging. It should address small groups of visitors, because either they have individual visitors or they have larger guided visits. So it should be suitable for both types of groups. And then for the learning goals, it's quite complex, but at least visitors should understand which components they need to create a battery, and how these can be used to increase the capacity, the forming time, and the lifetime, and then also understand what process exactly Henri Tudor proposes. So when we thought about this, our first idea was, why not using a tabletop? Because, I mean, we have seen many examples in museums where tabletops are used, and quite engaging and collaborative and so on. But then we thought that the problem is, if we want to really show this, how it felt in the time of Henri Tudor and the tools and equipments they are using, then it might not be that well suited. So we thought that it's maybe better to think about a custom design, custom space with custom objects. And so we discarded a little bit the idea of a tabletop. And yeah, we started an iterative design process with several prototypes. And this is the first prototype we did. So we started to think about a workbench instead of a tabletop, which then would look like the tools Henri Tudor was using. So in this first iteration of the design process, this was the result. So we said we are using 4 main components. So the workbench, an interactive notebook where you could check what the different components are, a battery casing where you could compose different types of batteries, and then to see how the capacity and so on is changing graph paper, because that was also the only thing we could think about what is appropriate for the time. Then we tested this workbench and to see what happens if there are 20 people standing there, what happens if there are 4 people standing there. So we tested this in our small group and just putting ourselves on different positions. And then we said it's better to have a straight workplace, because like a tea table or something, then it's always a lot of people who are not really seeing the screens. So we decided for a straight workspace, and we put all the screens in an angle, so then you can see them from many distances. And then in the next iteration, we created a functional prototype. So we bought material and to see how it's working, what sizes are appropriate. And one core component is a transparent screen. So we use a transparent screen because then we can actually insert the plates and we can add some effects, so some kind of augmented reality approach. But then was the question, how can we track these plates, that they are really reliably detected? So we decided to work with RFID, but we had to test where exactly to position them so that everything is well detected. So that was a little bit the purpose of this iteration. So then we decided to keep it all pretty simple, or try to simplify it as much as possible, and we decided to use 3 inputs and 3 outputs for the model, which was approximately the simplest we could think about, to nevertheless deal with the material we had to. And then we decided to base all the physical manipulations on inserting objects into the casing. Because, I mean, if you think about how can you make interactions as realistic as possible, it would mean I have to open a bottle, or even with this paste, I would need some kind of, I don't know, brush to put it on it. But all this would get so complex because there's so many different actions to do that at the end we said we just add everything in the casing. So a plate in the casing. If you want to add the paste, you put a small red thing next to it, and also the bottle is put in the casing. So then based on this, all became a bit more clearer and consistent. So then we thought about effects, how they could be shown. So with graph paper to show the curves, how they are increasing, decreasing, and what could be shown on the screen, on the transparent screen in the casing. And the workflow then is basically 3 steps: insert components, form or use the battery, and then view the results on the graph paper. Yeah, and then the setup in the museum. So then we went to the museum and we worked many long days in the museum. We laser cut the battery casing, inserted everything more high fidelity way, added the RFID antennas. With the transparent screen, it was also important to work with a good light. So we put some light LED strips on top of it, the white thing, what you see. And then we decided to put the wheel to turn, because otherwise, I mean, you need to, for one test, you need to pass 52 weeks. So if you want to push 52 weeks times on the button, it's getting really long for one experiment. So we decided to use some kind of wheel. Yeah. And then, the decisions we took as part of this iteration, so the exact shape of the object, so that they look really from the time of Henri Tudor, so these old chemistry bottles. We created some plates, which also should look as most like the real plates. And yeah, some pictures also to be used as part of the book. And then we created the visualizations, like you see here, where the protons and the electrons are moving. And then in addition, the problem we faced then is that it still seemed quite difficult to use or to really do the right procedure. So we added some feedback messages of Henri Tudor. So each time the visitor is doing a manipulation, he gets a feedback. Here, for instance, Henri Tudor is saying, incredible, the lead oxide is shortening the formation time a lot. So we meant to do it also a bit funny. This is why we've done it that way. Yeah, and that's now how the final prototype then looked like, how you can operate the books, get information. That's the casing, so you can add the plates and the electrolyte. And then you see the level increasing. And then you can form, and you see the protons and the electrons moving. And here you see the capacity increasing. And also the lifetime. So for how long does it break again and goes down very quickly, or does it keep for quite a long time? Yeah, with regard to the conclusion, so what can we learn about this? So first of all, the prototype, we did it, or the exhibit, we did it in multiple iterations. And actually each iteration we used a different type of prototype. And this allowed us to address different aspects also of the design. So the first was more about the spatial configuration and for the type of groups we are targeting. The second was about the model and the interactions. So to simplify it and to make coherent interactions. And the third about the form and the feedback. So how exactly, what shape do they show and what kind of atmosphere do they reflect. With our custom spatial configuration and the tangible interactions, we could address multiple types of groups. We could create a more realistic setting, and we could support engagement and learning by doing. The concrete interactions to handle a complex topic, they provided some additional usability challenges because it was so diverse that it would be impossible to find everything out by themselves. And we proposed to address these challenges by simplifying the model, making interactions coherent, and adding feedback messages. So, that's it. I'm right on time. I'm really proud.
Best thanks to you all. So we've got time for some questions. Anybody? In the audience? Raymond down the front here. Sorry, Florian first.
Florian Diber, DFKI. Nice work. Have you already deployed it in the museum? Maybe I missed that.
Yes, it's already deployed.
Okay.
So it was deployed in the third iteration. So we deployed it and then we improved it slightly for some based on some observations we made.
Okay, and but you haven't yet collected some user feedback from the visitors?
We have collected a lot of data.
Okay.
Mostly logging data. So we added some logging information about how long they interact with the exhibit, what kind of interaction they do. As much as we could log. And we provided a questionnaire which visitors can then fill out at the end, which checks a little bit what they know about Henri Tudor and the battery, no, only the battery, sorry, and the user experience, the NASA TLX, but it's all in the lab and not yet evaluated, so hopefully it's something for next year.
Yeah, hi, Raimund Axel. This is just great work. I just wanted to congratulate you. Actually, I don't have a question. I only wanted to say this is really great work, and I especially liked your iterative design process and the outcome, and also the idea of not using a tabletop. I love that. It's strange, I shouldn't say it aloud here, but it's really great to to distribute, actually. I mean, to distribute the action in physical and tangible objects, and the centerpiece alone. This is really a brilliant piece, not just of engineering, but also it's really attractive as an interaction object. So I think it was a great design decision to still have a surface with all these objects which look a little bit like the time, and still have it interactive. So it's a multi-display environment with different input modalities. So therefore, it's really great work, and congratulations on that.
Thank you.
Any other questions? I'll ask one question while the next speaker sets up, if you can. Sorry, Ed?
Yeah.
Oh, sorry, I missed it. Sorry, go for it.
Okay. Edward C. with NUITech. I really like the simulation aspect of this work. It was really great, and I was wondering, there were different configurations that people could try to see what would get the optimal battery. Like, was it like a little game for them to play to get like the most powerful battery?
Yes, this was actually also something with the first observations in the museum. We realized that it was not clear enough. People need a clear task, otherwise they are confused and they don't know what to do. And the clear task is actually to recreate the invention of Henri Tudor. So how to get a battery with a short formation time but a long lifetime.
Yeah.
So it's still pretty complex, but that's his invention. And so each time they get feedback from Henri Tudor with regard to this. So, for instance, if you put the wrong electrolyte, he says, I'm not sure this is going to work, or something like this. So really to help the visitor getting towards this goal.
That's a really great simulation environment. It's a great way of learning, so thank you for doing this. Great job.
Okay, let's thank Valérie again.